Hi there, welcome to Sense Tech. This is Jeevita. In this video, I'll be explaining you about recursion. What is recursion? Recursion is the process in which a function calls itself directly or indirectly. For example, have a look into this function f. It is calling itself f, f and f again and again for 3 times. Just like that, in programming, the function f of n is calling itself again and again. Here, f of n is a function which is defined, which will call the same function where n is reduced to 1. I think you know how to define a function. This is the prerequisite of this video. At least know how to define a function so that you can understand recursion in better way. Now let us see what happens if I execute this code. I am writing this code in VS Code and I am using Python to execute this. I am defining a function called f, which will take a parameter called n, and the function f will call the same function where n is equal to n minus 1. Let me call this function in the main function. In Python we don't write main function, so I am just calling this here. I am giving it as 5. You can give any number, and let me execute this. To execute, see, maximum recursion depth exceed. Here what's happening is a segmentation fault or stack overflow is happening. That is, the memory is limited and the code we are writing is calling itself again and again and again infinite number of times, and it is not stopping at all. So what happens is it will run forever and the code is running for infinite time, but we have limited memory. The memory is finite, so it can't store all the function in memory. So it is giving me an error called maximum recursion depth exceed. Let us trace this out so that you will get a clear picture of what's happening in this function. Okay, what I did was I have assumed the n value is 5. So I'll put 5 in place of n here. In the place of n, I have put 5. So what this function does is it will call itself where n is equal to n minus 1. But what is 5 minus 1? It is 4, right? So it will call f of 4. What does function f of 4 does? It will call f of 3. The function f of 3. What does f of 3 does? It will call f of 3 minus 1, that is f of 2. What does f of 2 does? It will call f of 2 minus 1, that is f of 1. What does f of 1 does? It will call f of 0, f of 0 will call f of minus 1, f of minus 1 will call f of minus 2, and it goes on up to infinity. To overcome this infinite loop, that is stack overflow error, we are using something called base condition. Base condition is a condition which will helps to stop the function. Here the function f of n is calling f of n minus 1. It will call f of n minus 1 until this condition is met. Once this condition is met, this function will be returning. This function will be returning none. Let me trace it down so that you will get a better understanding. Okay. Now this function f of n will check if n is less than or equal to 0. If so, it will return, or else it will call f of n minus 1. Let us assume the n value as 5. Here I am replacing this n as 5 and I'll check if 5 is less than or equal to 0. It is not true, right? So I'll go and do f of 5 minus 1, that is f of 4. Now f of 4 is called And again this f of 4 will check if 4 is less than or equal to 0. It is not. So it will call f of 4 minus 1. And again this f of 4 minus 1, that is f of 3, is called. F of 3 will check if 3 is less than or equal to 0. It is not. So f of 2 will be called. And then again f of 2 will check if 2 is less than or equal to 0. It is not. Then it will call f of 2 minus 1, that is f of 1. And then again f of 1 will check is 1 is less than or equal to 0. It is not. So it will call f of 1 minus 1, that is f of 0. And listen carefully. Here f of 0 will check if 0 is less than or equal to 0. It is true. So it will return none. I'll repeat. This f of 0 is equal to 0 condition is met. This condition is met. So this will return none. So this none will be received by f of 1, and f of 1's result will be returned to f of 2, and f of 2's result will be returned to f of 3, and f of 3's result will be returned to f of 4. In the same way f of 4's result will be returned to f of 5. As this is returning none, the none will be returned everywhere out throughout this function. So we will be not getting anything in the output. Let me just code this down and explain you. Like I'll check if n is less than or equal to 0. If it is true, I'll just return out of the loop. So let me execute. I should not get anything in the output. See, I'm not getting anything in the output. What if I'll just go and print n here? See, I'm getting 5, 4, 3, 2, 1. How I'm getting 5, 4, 3, 2, 1? Let me explain. Here, f of 5 will be called, that is where n is equal to 5. It will check if 5 is less than or equal to 0. It is not true, right? So this will not execute this if statement and jump into the outer statement, that is print 5. So 5 is printed. And then again call f of 5 minus 1, that is f of 4. So f of 4 will be called, and if 4 is less than or equal to 0, it is false. So this if condition will not get executed. So 4 will be printed. 4 is printed. So again f of 4 minus 1 will occur, that is f of 3. Whether 3 is less than or equal to 0, it is false. So print 3. So 3 is printed in the output. Just like that, it will print until n becomes 0. And once the n becomes 0, it will return none. But why I'm not getting none here? Because I'm not printing the output here. If I print the output here, I'll definitely get none. Sorry. Like see, I'm printing the output. Let me correct this to n. See, I think my code is perfect now. Yeah, I'll just execute it. See, I'm getting none. That is, this function is returning none. Nothing is returning out from this function. But this print statement will print from 5 to 1. Now, what if I'll print this down here? What happens? Let me check. See, I'm getting 1, 2, 3, 4, 5. But before I was getting 5, 4, 3, 2, 1. Why it is so? Okay. Like, let us see how function call happens in memory. As we know, stack will follow first in, last out approach. We are using stack to explain this recursion. So here I have defined a function f of n. It will check if n is less than or equal to 0. If so, it will return none. If not, it will return f of n minus 1 and print n. Now the main function is calling for f of phi. See, the main function will call for f of phi. As the main function calls f of phi, it will wait in the stack until f of phi will return something. So now f of phi starts executing and it will check for the base condition, that is phi is less than or equal to 0. It is not true. So it will go and execute f of 4. Until f of 4 will return something, f of phi will be waited in stack. See, f of phi will be waited in stack, and it even knows it has to perform some task associated with this. See, here f of phi have to perform print statement, but before going to the print statement, it is calling the function f of 4, but it has to do some function. So I am writing this p in front of f of phi. In the same way, f of phi will check for the base condition. As this is false, it will call f of 3. Until f of 3 returns something, this f of 4 will be waited in stack. And again f of 3 will call f of 2. Until f of 2 returns something, it will wait in the stack. Now f of 2 will call for f of 1. Until f of 1 returns something, f of 2 will be waited in stack. Now f of 2 is calling f of 1. F of 1 will call for f of 0. Until f of 0 returns something, it will wait in stack. Now have a close look into this. Now f of 0 will not call anything because the base condition is met here. 0 is equal to 0. So this will return none. See, f of 0 is returning none to f of 1. Now f of 1 knows it has to print something. See, it has to print something, that is n itself. So it will print n, that is 1 in this case, and return none, that is the input it has received from 0. The 0's output is the input for f of 1. So f of 1's output is the input for f of 2. So f of 2 will receives the output from f of 1, that is none in this case. So once it will return to f of 2, f of 1 will be popped out of the stack. Now f of 2 know it has to print 2. Once it print, it will return none to f of 3. In the same way, f of 3 knows it have to print 3. Once it print 3, it will return none to f of 4. Now f of 4 will print 4 and return none to f of 5. F of 5 will print 5 and return none to main function, and the main function will also return nothing. So this is what I'll get as output. So I'm getting 1, 2, 3, 4, 5 instead of 5, 4, 3, 2, 1. I think by now you have got a clear picture of how recursion works. Thank you for watching this video. Please do like, share and subscribe so that you'll get more content like this. In the next video, I'll be explaining you about sum of n numbers in recursion. Thank you.